because if there are any questions or comments, or I just put my own PC together last week. You can share them with the class. No, nobody did, other than myself. Okay, so let's go ahead and get started with that one. So I'll go to the Google Drive first, and also go to Moodle at the same time. The last week was just kind of really busy. We might actually get to that point and talk about how to run a web server. I basically have to fix a few things with a particular web resource, which may be of some help to some of you. For instance, if you think that the terms that we talk about in this class is a little bit kind of technical, and you want to get a maybe more in-depth treatment of computers, applications, security, and that sort of thing, here's a website that you can actually go to and perhaps learn some of those terms and some of the background information at your own pace. It's not going to be graded. The website is called learn.caconnect.org. This site was put together by mostly ARC faculty using a grant from, well, that's the advertisement. We can actually crank up the volume, and then I can advertise this.
Hi, and welcome to California Connects and Living with Technology. Technology and computers are a big part of our everyday lives. We have scanners that record purchases and other transactions, ATM machines for banking, terminals recording important time changes, and cell phones connecting us to the world. Did you know that the world population in 2011 is 7 billion? That in 1995 there were only 16 million internet users, but in 2011, 2 billion internet users, and there will be 5 billion internet users in 2020. Did you know that looking for a job on the internet reduces your unemployment time by 25%? Did you know that 3 out of 4 Americans use the internet? Don't get left behind. Learn how to use technology. The World Wide Web is the largest library in the world. We want to help you learn how to access the World Wide Web and how to use email to communicate around the world. We call it Living with Technology. We will show you how to use computers with a comfortable and easy to learn set of lessons. Let's begin now. Living with Technology.
So that's a little promo for this particular website. Most of this stuff is probably, I would say, around cisc310, or some of this may be cisc100 material, which in this class is a little bit kind of elementary. But there are different parts of it too. You can see that there are different buttons here. They're kind of hard to see, just hover over it. Starting with desktop, internet, email basics, software application. So that one, I would say, is already kind of relevant to us, because that's what we kind of talked about too in this class. Advanced internet, shopping. So that basically refers to shopping online. And then you can roll over to the this one has to do with internet resources, the cloud, how to do library research, accelerating with software. I think that's just software application, but more advanced. Online learning, how do you locate a community college and stuff like that. It's definitely general purpose. We have people who use this website for in a senior center to teach people in senior centers how to use computers. You can use it any way you want to. It's completely free. It's online, and you don't have to sign in or be a student to access the resources. Like right now, I'm not even signed in yet. You can see that I'm not signed in. And I can go to any resource and actually access the content. You cannot participate in the quizzes if you're not logged in, but you can definitely still view the content. It can still be useful. Okay, if you find out that there's a few topics here that is more in depth, and you feel it's useful, hey, make use of it. It's free, it's on the internet. So are there any questions about this particular website? It's called Living with Technology, but it's really put together by the California Connects grant, which specifically target the Central Valley. But since this is on the internet, it's accessible to everybody. No particular questions about this one? No? It's just one more resource that you might find useful, for yourself or for people that that kind of thing. Getting back to the class here, the conditional statement one is now open, and I postponed the due date by 2 days, because I made a mistake in terms of the grading. So people who have done it already might have to do it again, just so you can get a score. It's not very long. You can keep the same answers that you had already. So it's not like I changed the questions themselves. It's just how they are scored. Are there any questions about the new not so new anymore, the homework assignment about branching?
So how do we get to that?
Huh?
How do we get to the new homework assignment?
You have to finish the other one first. Okay. So what you need to do is to go to topic 6. Finish the first one called the first Scratch program, and then once you finish that one, the second one will open up.
Are you going to accept them late? Because I was having problems with my computer, so I need you to do the first one.
The first one?
Yeah.
The first one, let me see how I set up the due date. I think it's past due already.
Oh yeah, it is past due. I'm just.
Yeah. Since it's past due already, you can go ahead and do it, just so that you have access to the second one. But the due date is still kind of the 4th and the 11th. So just say they're due on 4/11. So this way you can still do it, but just so that the second assignment will open up for you. All right. Any other questions? Yep. Go ahead.
I did that first Scratch program when it was first available,
Uh-huh.
and I don't think I got a score on it.
Okay, you can do it again. So,
Okay.
Yeah, so go ahead and do it again if you do not get a score after you did it the first time. The answers are still the same, so you don't really have to read through the whole thing again if you remember your answers from the previous time.
How
Yep.
many answers? How many questions?
I cannot remember. This is what we call a lesson. So in other words, it's kind of like a guided tour on a particular topic. So each page starts with some information. It talks about a general concept, but at the end of a page there will be a question. Usually it is linked to something that you have to do with Scratch in this case, and then you have to answer the question based on what you do in Scratch. And then if you answer correctly, it will move on to the next page. And so you basically walk through the entire lesson this way. And there will be points. Yep, go ahead.
Okay, I read the whole thing and question number 8. And it was correct too. And once I click, it just stopped.
It just stops. Okay, do you see a score in your...
They say 8. You have 8 out of 8.
8 out of 8? Okay, so that should be your score.
That's the,
Yeah, you can check it in your grade book. The score should register in your grade book. It does not?
No.
Okay. I cannot check right now, because if I check right now, you guys can see the score of everybody on this assignment, but I can check later. Sorry? But I can check later. Worst come to worst, we'll just make this one due on. I'll just make this one due on the 18th too, because I think a few people started on the second one. That means the first one has to be completable in order to start on the second one. Yep.
I took a conditional statement and I got a grade on it, but the questions that were kind of weird. There's some of your questions had a yes or no answer, and when I click yes, it would say it's wrong, but then I click no, it also says it's wrong. But then when I was done, and then it gave me
Is that the first one or the second
the
one?
second one.
Yeah, I fixed the second one.
So do we have to do it over again, even though I got it?
Yeah, you have to do it again, just so we can get the score. Sorry about that.
No,
Yep.
the second one, you didn't show me So you have to complete the first one.
You have to complete the first
You
one
like-
with 50% or more as a score before you can get started with the second one.
So when I complete, the first one, stop and 8.
Just if you don't see a score in your grade sheet for the first one, do it again. You can do it. You can reattempt it as many times as you want. Yep.
It doesn't show. I tried.
Do it again. Yeah.
It say it's closed on 11.
Yeah. I just reopened it.
Oh,
Yes. You had a question? Oh, okay. All right. So I'll just make the first one due on the 18th too. So this way, both of these assignments will be due on Thursday.
Thank you.
Re-enable the due date, but this time I move it to the 18th, and we'll make it 9 o'clock. Yep. Go ahead.
Did you pass on roll sheet?
Nope, roll sheet has not been passed yet. Thank you. Thank you for the reminder. All right. So here's Google Drive, and here's the document again. And this time, I spent some time to kind of beef it up a little bit. So it's kind of like a reminder of the topics that I have to talk about today. Last time we were talking about motherboard selection, and that's where we'll start today, is to go to the book again today and get started with the selection of motherboards.
Has that Google Drive document been sent to us?
It is already accessible from Moodle. You log into your Moodle account, you move back to your topic number 2, and then the last link is how to put your PC together. It is a Google Drive document. If you click on it, you can view it. All right, so let's get started with the document, and also go to newegg.com and actually take a look at the motherboard selection process. So I can really talk about this, and some of the things that I was only talking about last week, this week I can talk about it, with personal experience, because I just integrated these components into my older PC. So I replaced some of the components, and I can kind of really tell you guys about, the process itself, and not just to look at things from the perspective of numbers. Okay, so we're now trying to select a motherboard. A motherboard is basically the centerpiece of the entire personal computer. It connects all the components together, and that's why the selection of the motherboard has a lot of implications. I'm pretty sure AMD has really capable processors too, but since I only used an Intel processor in my own process, we'll just go take a look at Intel motherboards at this point. We talked about the socket types last week, and we talked about how socket LGA1155 is the most popular socket type at this point of time. And that's why it's also something that you have to consider is what type of socket, because once you select a socket type on the motherboard, you can't really switch, okay, except for AMD sockets which are backward compatible, but they're not future compatible. Okay, so you still have to consider do I want to select socket 1155 because I have a huge selection of available processors, or do I want to select LGA 2011 because they have high-end processors? Okay, the high-end processors, last time we checked, some of those were pretty expensive. Did you guys remember the general pricing of a LGA 2011 processor from last week? Nobody remembered. Yep.
It was, I think the cheapest was like 600,
Mm-hmm.
and the top was about a little over 1,000.
Yep, just a little over $1,000. And then since Newegg is in California, you have to pay the taxes for that. So by the time you get it, it's $1,200 already. Okay, and that's a lot of money. Okay, do you guys still remember that we looked up Tom's hardware in terms of benchmark? The top of the line processor, the ones that's $1,000, compared to a $300 one. Do you remember what was the performance gain for all that extra money? It was, I think it was 12 versus 9 or something like that. It wasn't even double. Okay, if you buy a processor that's $1,000, it doesn't have even twice the processing power as one that you can buy right now for about $300. Okay. We also talked about Moore's law last week, which basically says processor speed will double every 18 months. So if you spend the same amount of money, but spend the money like 18 months from today, you'll be buying something that has about twice the processing power as what you'll be buying today. But that's a really important statement, because what it's saying is if you can just wait a little bit and delay the purchase of a high-end processor, you'll be paying less money, or if you spend the same amount of money, you'll be buying a faster processor. Okay, so you kind of have to find the best price point at where you can know that you can say that I know the price of this processor won't go down much more, and it has all the processing power that I need at this point, and also in the near future. Okay. So that's one thing that we have to consider when we select the socket type, because once you select the socket type, you really cannot change it. You have to change the motherboard and potentially change the other components if you want to do this. So let's go ahead and pick LGA 1155, because we have a huge selection of motherboards in this case. The next thing you have to select, or you have to kind of consider, would be one thing is the form factor. Okay, so let's turn on the more option part here. Form factor may or may not be important to you. We have, generally speaking, 4 different types of form factor. Out of these 4, I would say 2 are really the most common ones. The first one is obviously common. The first one is called ATX. It's basically the quote-unquote full-size version of a motherboard. It's the most common type of motherboards you can get. The second one you can see is extended ATX. It's bigger than a regular ATX motherboard. Let's do the measurement here. This is one that I have not really used ever. It does look a lot bigger, size-wise. It's bigger than a normal ATX motherboard. So you need a special case for something like that, and you don't really have a good selection either. So let's go back to motherboards here. This one is interesting. Micro ATX is a smaller ATX motherboard. It will fit into a normal case. It can also fit into a smaller case. How many people have a concern about the size of your desktop computer? Most people don't, because you do.
I have an Alienware box that's the size of, it's huge.
It's huge.
It's just crazy. And loud. It's
Well,
old, but.
Yeah, but Alienware is they specialize in gaming hardware, and in gaming hardware you have a lot of heat producing components, and that's why it has a lot of fans, and when you have a lot of fans, it feels like a jet going off every time you turn on the computer.
Well, the person that gave it to me was a gamer, and he set it up for me because I'm just like basic, So then I had somebody else go back in because it crashed like really hard, and then I had somebody else go in and put some new stuff in there, and they put another fan in there, and now I'm working with a Mac.
Okay, so you don't use
I have
an
this box
Alienware.
that's just.
It used to be expensive. I'm pretty sure that box, anything from Alienware used to be, expensive.
Yeah.
But depending on how old it is, it may not, it may not worth a lot of money now. Because what happens is.
If anybody's interested in it, I want to get rid of it. So I just don't know how to.
Wipe the hard drive.
I don't want to.
Oh, there's a hand
Are you
over there.
looking to get any money out of it, or are you just want it gone?
I want to get rid of it safely without having my stuff that's in there, because I still have like all my personal things in there.
You can take out the hard drive. You can just disassemble it, take out the hard drive.
I think Best Buy does some electronics recycling. But yeah, look up some electronics recycling places online.
Well, if you want to get rid of it, and don't want to pay for, someone to pick it up, you can go to the county landfill and get rid of any type of e-waste for free.
Okay.
Yeah, I used to, I still do it. I have, big boxes in my house that I put all the e-waste into. So when those boxes got filled up, I get a few boxes of those. I just put it into my minivan. I drive to the county landfill, and they just, they will direct you to a dumpster. And there are two basic dumpsters, one for general electronics and the other one for computer-related electronics. You just go out there, throw it, and and drive away. And you can do it for free. You can also get rid of your e-waste in some charity events, because some charity organizations can actually get money from your old computers and whatnot. So that's also something you can
Who does
consider.
the charities? Just look up charities that do
Just
computers?
various organizations, schools. ARC sometimes has that kind of that kind of event too. You can also go, if you don't want to go to all the way to the county dump site, which is kind of far out there. You can bring it on campus. Our printing center, actually has a recycling part to it too. So you might want to check
The one
with.
that's over by the admissions office?
Yeah.
Okay.
Yeah. So you might want to kind of check with them. Just call them up. So I'll give you a number. So you call up, ARC printing services. The guy who's running the printing services is also in charge of the green movement on campus. So he probably will tell you, whether you can dump your e-waste stuff over there or not. So let me look up the number. Let me see if I can find the number. This is his email address. So let me. Can you read it? It's pretty hard to read.
Yeah, I got it.
don.read@arc.losrios.edu. Because I know they accept old batteries. If you have like alkaline or rechargeable batteries that don't recharge anymore, you can actually take it here. And location-wise, it's really within 5 minutes of walk from this classroom.
Yeah.
So that's a convenient place for you to go to. If you're on campus already, you just kind of have to pull that thing around, until you get to that place. Or you can just stop, with a closer parking space and just take it out and move somewhere else.
Thank you.
Sure, you're welcome. Right. So back on topic here. So since we were talking about the cases, micro ATX is a smaller type of motherboard. It is not fully compatible with a full-size ATX. In other words, if you have a case that was designed only for a full-size ATX motherboard, and you purchase one of these, smaller, it's called a micro ATX motherboard, it won't fit exactly. Okay, so the screw holes, the placement of the screws, would not fit, 100%. So when you purchase a case, you kind of have to prepare for the size of the motherboard that you're getting. Size-wise, these are smaller, but because they're smaller, they also have more limited expandability. You can look at this part here. This one only has 2 memory slots instead of 4. A full-size ATX motherboard will typically give you 4 memory slots instead of 2. Okay, but they fit a niche, where you want to have a smaller computer case. So you can basically hide your computer under the desk or behind the computer or behind a monitor, so it's not in your way. Okay. Are there any questions about the size or the form factor of a motherboard? There's a third one, which is even smaller. Let me go back to the previous screen so we can select that particular option. Scroll all the way down to form factor. The last one is called Mini ITX, and you can see that there are not a whole lot of options, but these are tiny. I'll just click on one, and open a new tab. So just so that we can see the size, how they compare to a full-size ATX motherboard. So then I'll go back to the previous screen, go to a full-size ATX motherboard. Then we can actually see the sizes, how they compare. Let's pick, we'll just pick the first one. Okay, so this is a full-size ATX motherboard. You can see, how many slots, there are. There are like 6 of these, slots on the motherboard, which means, you can actually expand the motherboard's capability quite a bit, before it runs out of expansion slots. I just wanted to go to the size part. Okay, right here, the dimension of this one is 12 inch by 7.8 inches. So it's pretty about the same size as a letter size piece of paper. Okay, that's a full size motherboard. And since we were talking about paper, I should pass around the roll sheet. And it's out of space, so just kind of add your name, to the column next to the 11th. Okay, so there you go. Is that the right class? Yeah, it is. Okay, so this is a full-size ATX motherboard, and let's go back to this one that is tiny. This is called a mini ITX motherboard. The size is 6.7 inches square. Okay. So this one is quite a bit smaller than the other one, and therefore you can buy a smaller case, and then the computer you can put it behind the monitor easily with a mini ITX case. Are there any questions about the size of the motherboard or the form factor of the motherboard? No questions? Okay. How many people have actually put a PC together, like hooking up components to a motherboard? Okay. Did you do it with a full-size ATX motherboard or a mini How many people have tried a mini ITX motherboard? Would you say that's easy?
They're all pretty easy.
They're all pretty easy, but with a smaller board, it's actually harder to get the connectors to where they're supposed
Cable
to.
routing is more difficult, but
Say again?
instead of routing the cables, like the wires, that's the only real difficult part.
Yep. Plus, you don't have a lot of space either. It also depends. We'll get to that point. It depends on how big of a CPU fan and heatsink you choose to use, because there are really big CPU fans out there too. So, are there any questions at this point? If you don't have any particular need for a smaller motherboard, I would say a full-size motherboard is probably better. Okay? Just because it's inexpensive. Okay, just look at the prices here. We'll just go from best rating. And the best rating one with 34 reviews, with 5 eggs out of 5, is $160 for the full-size, ATX motherboard. And then with this one, which is a mini ITX motherboard, I lost that form factor selection. You can see the smaller the motherboard doesn't mean it is any less expensive, because you can still see kind of expensive ones up to $190. You can find that these things do not have as much expansion slots. Getting back to here, let me see if I can find the one that I bought. I think I bought something that looks like this. We'll just click that. So now that we have selected a particular motherboard, we'll go through the specifications of the motherboard and we'll figure out what is important and what is not. Much of this stuff is already discussed here in terms of socket type, form factor, memory, number of memory slots. So we'll just go there, with this one here, go to details. I think this is something that we did last time too. This one has got 4 memory slots. When you have 4 memory slots, when you populate memory, you have to populate 2 at a time. So when you first purchase your motherboard, you will have to buy 2 memory modules to install on the motherboard. So the next question is, how much RAM do you actually need for your computer? And do you want to be able to expand it later without having to throw away components that's already installed on your motherboard? I wrote down here in my notes, which is also accessible to you. If you only have a general purpose computer that you go online, browse the web, occasionally play a few simple games, especially online games, 4 gigs of RAM is not too small. I mean, I think 4 gig, you can get away with 4 gigs of RAM with a general purpose computer. If you want a higher end computer, because you might want to run some higher end applications, 8 gigs of RAM, from 2 4 gigs of RAM modules, that should be enough for a lot of people. How many people have experienced that I'm running out of RAM even though I have 8 gigs of RAM, and not counting gamers or any special purpose type of computer? Okay, so most people can live with 8 gigs of RAM. That will cost you about $80. Okay, 8 gigs of RAM will cost you about $80. 4 gigs of RAM is about half that price. So buying more RAM really doesn't mean that you pay less per gig of RAM. It's really about the same when you're just calculating how much am I paying for each gig of RAM. Now the last configuration here is combining 2 8-gigabyte memory modules for a total of 16 gigs of RAM. 16 gigabytes of RAM is a lot of RAM. Okay, most people who have this type of configuration will be either running a database server, because you want to cache as much stuff in memory as possible when you're running a database server. You can run virtual machines, a lot of virtual machines, or you're in serious gaming. How many people in this class have 16 gigs of RAM on your computer? Okay, so we have about, I would say about 6 people, out of a class of 40 who have 16 gigs of RAM. How many people have 32 gigs of RAM? That's a lot of RAM. What do you use it for? Gaming. Do you see a difference between systems with 16 gigs of RAM and your system with 32 gigs?
Not much, but it really
Depends on the game. Depends on how much you can preload into memory. Okay. Well, that's a lot of RAM. Now, but that really brings up the next question. What if you install 16 gigs of RAM today, and then 4 months later, a new game comes out, and then everybody says, you need 32 gigs of RAM to run this game correctly, okay? That depends on your motherboard. If you purchase a motherboard that only has 2 memory slots, then you have no choice but to take out the 2 memory modules that you purchased today and then swap in 2 16 gig memory. Each memory module is 16 gig, and then you have to swap in 2 of those later on. If you have a motherboard that has 4 memory slots, then what you can do is to purchase 2 additional memory modules, add it to the motherboard, and you're done. So that's why when you're selecting a motherboard, with 4 memory modules, that gives you the ability to expand in the future without wasting what you have purchased today. Yep.
Why remove 2? You just move 1 and then upgrade 1 chip.
You cannot upgrade just 1 chip. Memory modules, they have to go in pairs
Why is that?
because of the dual channeling of the memory bus. So you have to, for best performance, you really need to replace both at the same time. Yep.
This would be assuming that the motherboard is expandable to that much memory.
That is correct. Most motherboards are expandable to up to 32 gigs now, but that number obviously keeps changing because it depends on the chipset as well.
But older motherboards.
Older motherboards and also the processor, because we lost the memory controller in the North Bridge, so now it's in the processor itself, and also the motherboard, how they route the signals. Question? Go ahead. No. Okay. Go ahead.
So, by what I understand, if you have 4 slots, you can have 2 4 gigs and 2 8 gigs.
Yes, you can mix the 2 pairs, but within each pair they should be symmetric.
So they have to be from the same company then?
They don't have to be from the same company, but they do have to have the same latency time. So in terms of delay and performance, they should be matching, because otherwise you'll be paying for the more expensive one, the faster one, but you're only getting the performance of the slower one. So you don't want to do that. You want to have the two of each one in a pair should be the same as the other one.
So when they sell them, they sell them as a pair?
Yes, they do. Yep.
With memory modules, you really really need them to be pretty much the exact same stick, or you will run some serious issues down the road. I find that if I try to mix, if you try to mix even manufacturers, even if they have the same rated.
So you have to
specs,
buy them as a pair because they were tested as a pair
Yeah.
by the manufacturer.
Usually, if you don't, you usually get like a lot of blue screens, a lot of memory errors.
Okay. So that's why they sell them, as a pair within the same, blister pack, because the manufacturer tested those as a pair to make sure that they are functional as a pair together. Okay, that's a good point. Okay. Any other questions? Yep.
When you do that, it has to be compatible with a computer. Like I have a Dell, and I realize that sometimes when I buy things, I have to be careful because most of them.
There's nothing you can do just by looking at the outside of the case. You really have to open it up and find out what's in the inside. Or you can look up the model number of your Dell, look it up on the Dell website, then you can get the full specification of your computer. Yep.
If I remember correctly, Dell uses proprietary motherboards, and they only have proprietary memory to go with that motherboard, so you really have to order it directly from Dell.
You can order that from Dell, or there are other
Maybe
places,
third
third party that might sell that particular form factor of memory modules too. And that's one other thing that's good about putting your own PC together is if you put your own PC together and you use industry standard specification, you can pretty much swap things around without having too much trouble. Yep.
I used to work for the computer teacher when I was in high school. And, someone donated a bunch of these Dells, and it ended up costing us more to find the memory and all this stuff than it would have been to just buy complete new ones.
Wow, that's bad. That is bad. Yep. Question? Yep. Okay. All right. Are there any other questions about memory modules, or how do you select a motherboard based on the number of memory modules that you can plug in? Any questions? Now, this kind of exercise is useful even if you're not putting a PC together, because you can use pretty much the same specification and selection criteria when you're purchasing, let's say, a laptop computer. Now, most laptop computers do not have 4 memory slots. Some do and some do not, but it's the same consideration. If you purchase a laptop computer that has 4 memory slots, most of the time the manufacturer will let you select. If you want 8 gigs of RAM, do you want the 8 gigs to come in 2x4 or 4x2, configuration? They will charge you more if you want to have it in a 2x4 configuration, because it's a more desirable configuration. But with laptop computers, unless you purchase from a really kind of oddball company, most of the time they still have to use industry standard memory modules. They're called SODIMMs, SODIMM. So you can actually expand the amount of RAM on a laptop computer by purchasing memory after the fact from a third-party company. Okay. Any other questions? Questions? All right, let's move on. Yep, go ahead.
Can you repeat that? On the laptop part, you're saying the memory that's on there, there's a slot to expand it, so there's 2 slots?
Some have 2 and some have 4.
But again, laptops, the rules apply to laptops as they do to desktops.
Yeah, because SODIMMs are basically just small outline or small factor memory modules. So they're just smaller, but they have the same type of pin out.
So you can't use the same RAM on a
You cannot use the same one, because the ones that you use on the regular desktop computer, they're really big. Yeah, they're huge compared to the ones that you put into a laptop computer. All right. So the other things you have to consider, especially when you are a serious gamer, is how many expansion slots do you have, and what type of expansion slots do you have. In this case, I would not call this motherboard a very gamer-oriented motherboard, because it only has 2, one a PCI Express 3.0 and one PCI Express 2.0 16-lane type of expansion slot. That's not really a gamer type of configuration. If you want to have a gamer configuration, let's go back and take a look at the options again. You can see that PCI Express 3.0 by 16. This would be a good way to look at it is, if you have 3 slots, of PCI Express by 16 lane, that makes the motherboard gamer friendly, because now you can actually add enough video cards to get the best video performance out of it. I only have a passive, in my other configuration, my video card was a PCI video card. Not PCI Express, it's a regular old school legacy PCI motherboard, video card with no forced air cooling. It has a big heatsink on it, and that was it. So you can basically imagine the lack of video performance. But I only use it as a workstation, for word processing, getting ready for classes and stuff like that. So video performance was not one of the big things, it was not important to me. But because my video card does not come with its own fans, it's more silent, okay? As a whole, the PC is quiet. Okay. Any other questions at this point? No questions? Does everybody understand what I mean when I said the PCI Express? Okay. So, PCI Express is a way to expand the capability of your computer. Now, obviously, I'm not expecting you guys to read this entire wiki page. You can see how long the wiki page is. Just the first paragraph is all that you need. PCI Express, Peripheral Component Interconnect Express, is a high-speed serial computer expansion bus standard to replace the older standard, blah, blah, blah. It has numerous improvements, blah, blah, blah. Okay, so what it is it allows you to add additional components to the motherboard. So if you want to expand or improve the video performance, you can basically, add additional cards to your PC or swap out whatever is already on it with a higher end component. Then you can keep up with, the games and the demand of, other stuff that you're doing. Any questions about this? Yep.
So if you want to improve the quality of the video, you can either remove your old PCI video card or replace it with a new one, or if you have a PCI Express, you can put a new video, so you can have 2 video cards.
Yes, you can actually link up to 3 video cards now.
And
They can all work in tandem in order to give you, the best overall video performance.
So one doesn't override the other depending on the manufacturer?
I think you have to get the same type, so they can work together.
So they're just like the RAM chips?
So
They're just like the RAM chips?
they're much bigger. Physically, they're huge.
No, as far as like compatibility. You want to make sure
Compatibility, yes. You definitely want to get the same type, 3 of the same kind or 2 of the same kind, together. Okay. Any other questions about, PCI Express? This is one of the main reasons why people want to put their own PC together, is just for the ability to expand the capability of the computer later on. Okay. How fast do you think or how fast are the changes when it comes to video card performance?
Incredibly fast.
They still follow the Moore's law, right?
More or
Is
less.
it faster?
I think in the past 4 years we've doubled, maybe twice.
So it's a little bit faster than Moore's law.
Maybe.
No, wait. Okay, over the past 4 years, it improved 4 times. So that would still be following Moore's law more or less, because Moore's law says every 3 years, every 36 months it will quadruple, because every 18 months it's doubling. So it follows the same rule because it has to do with the silicon process, how we create, how we make these chips. So it still has to follow the same curve, which is doubling every 18 months or so. Okay. Do you guys want to take a look at video cards and see how much money you can spend on just video cards?
Sure.
All right, so I'm going to keep these tabs open because I think they're still useful. So we'll go to here and go to video cards, open a new tab for that. Professional graphics card. professional video devices, we'll just go for desktop because that's basically what we are looking for. And if you look at the pricing, you can actually see the curve here. It's not really a bell curve, because if it were a bell curve, you would see, $10 to $25 to have the least, and then $1,250 to $1,500 to have the least, and then you see a gradual increase and then a gradual decrease. But what we're seeing here is a dip in the range of $75 to $100. There are only 67 of those. But when it comes to $100 to $200, we have 172 options, and in between $200 to $400, together there are like 100 choices. Okay. So what do you think will give me a reasonably high performance video card? Yep.
$200 to $300.
$200 to $300. Well, let's take a look at that range. So that means one video card is going to cost you as much as you pay for just the main processor itself. Okay. But that makes sense if you're playing games, because the main processor really doesn't do a whole lot when you're playing high-end games. The video card actually does most of the processing when it comes to rendering the graphics. Okay.
Basically having a computer inside. I've heard the graphics card is basically like having another PC inside.
Oh, it's faster than your main processor. The graphics cards, actually have more processing power compared to your main processor. It's just that it cannot do general purpose computing as well as your main processor. But when it comes to raw processing speed, these processors have way more processing power compared to your main PC processor. Okay. So we'll take a look at the first one. They're still based on, I'm still sorting by best rating. So this is the first one that comes out, for about $300. We'll just take a look at it. Because it will show you certain things that you have to consider when it comes to your motherboard as well as your power supply. There are special considerations. The specification, is 1344 CUDA cores. Basically, one core is quote unquote one processor, so there are more than 1,300 processors working at the same time. Okay. So when you think about your main processor, the highest end desktop processor for about $1,000 will give you 6 actual hardware core and 12 logical cores. The graphics card for $300, gives you 1,344 individual processors. Now, granted, each individual processor is not really quite the same as a main process core from the main processor, but it's still a lot of processing power. Has 2 gigs of 192-bit GDDR5 memory. This part applies to memory. Is that a good number? Because I don't really do gaming anymore. Yep.
That's pretty standard.
That's pretty standard. Okay, so most games will be fine with this video card. Okay. Let's go down to here. PCI Express 3.0 by 16. So if you get a motherboard that cannot deal with PCI Express 3.0, you may not be able to get the most out of this card. Is it backward compatible? 3.0 is backward compatible to 2.0, but you may not get the best.
You just won't get the higher bus speed.
Okay, so you won't be extracting the most out of the video card if your motherboard can only support PCI Express 2.0.
Really, the PCI Express 3.0 is actually faster than the memory of the card itself, so you won't really see any difference.
Okay, I see.
But for future video cards coming out, maybe in the future, 3.0 might be a better choice.
Okay, so it's kind of like USB 2.0 versus you put USB 3.0. It depends a lot on the device itself to see whether you're saturating the bus first or whether the device is faster than the bus already. Okay, that makes sense. And then we go to details. Okay, you can also read all the advertisement stuff, which really is mostly gibberish. Right. I have some reservation about this brand, because of a motherboard that I purchased, from this brand. But sometimes, from the same brand, the different components are actually manufactured by different places and they're specified differently. So I wouldn't count it against them when it comes to video cards. And once again, the core speed, they're kind of important, but they're only important when you're comparing to the same brand and the same GPU. So what I want to show you is, oh, they don't show it. They don't show the actual power consumption of the video card itself. I'm kind of surprised that it doesn't show it. Because when you're putting your own PC together, you kind of have to know how much power to budget just for the video card. Let me see if I can find it here in the overview. Nope. That's not good. Does anyone have this card and know the exact or the specification of power consumption? Yep.
It's about 90, I think it's around 90 idle, up
Okay.
to around
200?
200, maybe 250 of those.
Okay, so let's do some math here. Okay, I'm gonna do the math on the PC, just so that we can figure out what the power budget looks like when it comes to putting your PC together. Okay, so we have the core processor that they pick has 77 watts just for the CPU, and then you have to allocate about 250 watts per video card. So let's say you want to have two of these to get really high performance out of your system. Then we are talking about 500 watts of power just for the video cards. The other thing you also have to consider, let me see if I can find it on the picture. So this is a bigger picture of the video card itself. It's big. Okay, I'm not sure whether you can actually see the size of this thing. It actually takes up 2 slots. It's that big.
It's about that big.
Okay, that's pretty big as a video card. It takes up 2 slots, on the back panel. Okay, because you can see how wide it is in the back. It has its own fan, and if this fan dies, the video card dies. Yep.
You can replace it.
You can replace it. So it has a thermal shutdown.
It should shut itself down if it gets too hot. Should.
It should. The question is, can it shut it down, fast enough? Because sometimes when it heats up, it can heat up
It
fast
usually
enough.
throttles itself way, it pretty much kills the clock speed.
Okay. And this is the back panel. You can see, the opening here, for air to. I think it sucks air in, or does it blow air out?
That's exhaust.
Sorry? That's exhaust?
Exhaust.
Okay, so air comes out of these holes. Okay. And that's a big, huge, you can see the heat sink here. It has 2, I think those are DVI connections. That's a HDMI.
That's DisplayPort.
That's a video display link.
DisplayPort.
Display port. Okay. Doesn't even have a VGA anymore.
They haven't used those in forever.
Why even bother with a high-end graphics card when you're still using VGA, right? Right. Yeah, but this is a pretty big video card, and that's partially why your PC, the Alienware PC, was loud. Some of the older designs of video cards may be very loud because they have multiple fans instead of one. This one only has one single fan on it. Getting back to this document, 500 watts, just for the video card, about 100 for the CPU. That means you're looking at about a 1 kilowatt power supply already at this point. And then when we talk about power supply, you will actually see the numbers can be very, very misleading. Are there any questions at this point? Yep, go ahead.
Okay, if I understand everything correctly in the past few minutes, the GPU has its own processor as well as what's on the motherboard.
It is a processor on top or in addition to your main processor.
So the processor, which is a smaller in speed compared to the GPU on the video card, isn't there like a bottleneck between the two when it displays them on the screen?
Yes, the PCI Express, or the PCI Express bus is the limitation of how fast you can get information from the main processor or from a game, loaded into the video card.
So the motherboard bus or
The PCI Express bus, to be specific.
You want to make sure that they're compatible, that there is no
Right, that's why you want to use, that's what he's mentioning, is PCI Express 3.0 has a higher ceiling of, communication speed between the processor and your video card. Whereas PCI Express 2.0 has a lower ceiling. And what you're saying is, the performance of a card like that does not exceed the capability of a 2.0 bus to begin with. On the other hand, if you have a 3.0 bus on the motherboard, then you can purchase a higher end video card later that can actually utilize that extra speed.
Understandable when this is for gaming and high-end video editing, like movies and stuff like that. But for the average Joe,
that's an overkill. Spending $300 on a video card, it seems to me, is an overkill, unless you're into gaming. Yep.
For general purpose computing, a lot of the I think i5s and i7s actually have a on-chip
and that's more than sufficient.
And it's usually sufficient for general purpose.
Exactly. Okay, so the i3, i5, and the i7 cores, the processors.
The i3 would have it.
The i3 has it too, I think.
Does it?
Yeah. The i3 processors has it too. It's one of the main thing about the new line of Intel processors is they all start with a video processor on chip. The server ones do not, because that's not what they're intended for. Are you getting what we just said?
I was leading up to that, but he kind of that's what's kind of trying to get to on the question. He jumped in.
If you're watching Netflix or watching DVD or even Blu-ray, you're not even coming close to the need of an extra video card. The extra video card really is mostly for gaming or CAD type of applications, computer aided design, 3D modeling. That sort of thing require a lot more processing power, because when you rotate a design and it has a lot of details, you want these more than 1,000 processors to help you redraw the entire thing instead of having your main Pentium processors doing all the work. Okay. I think the second choice actually gives us a better view of how massive these things are, because the first one put it inside a case that looks really clean and kind of it doesn't show the details. The second one does. Yep.
The second one's actually smaller.
It's actually smaller.
Yeah.
But it looks bigger because everything is exposed.
It might be wider, but in length it's definitely a lot smaller.
Okay. Yeah, but you can look at the fans. The size of the fans. These are bigger than the fans of your main processor. Now, because of the exposed design like this, if you have a cable that get caught in the fan, that would be a very, very bad situation. Because one, the cable can get cut. These things are really sharp. I got cut once by a processor fan, and I was surprised of how sharp those things are, because I did not even realize the cut until I see blood coming out of my finger. That's how sharp it is. I hope nobody else has that experience, because it's definitely not fun. Yep.
I was like, way back when I was like trying to deal with a graphics card thing like that, like those little buggers are really, really sharp. I actually had a similar encounter like that.
But there's a reason why the blades are so sharp, because the sharper the blades are, the more silent the fan runs, because it doesn't cause as much turbulence, which basically makes it noisy. You had a question?
Yeah, I was wondering if the fans themselves, are they plastic or metal?
They're all plastic.
Okay.
Yeah, the fan blades are all plastic, but inside there are metallic components, obviously. Yep.
I've actually seen some metal CPU fans.
Wow. They're good for chopping stuff. I cannot imagine why CPU fans need to be metallic. Let me see if I can
lighter
find a power
metal like
supply.
aluminum or something.
Say again?
I said they could be made of like a light metal like aluminum or something, allowing it to have a lot more rotation with less weight.
It still doesn't make sense to make it out of metal, because plastic is very flexible. So that's why they're more durable. If you make a fan blade out of metal and it's not flexible, you can bend it. And once you bend the blade of a fan, it doesn't balance anymore. So the bearing on the fan will go out much sooner than expected. and then you have to throw the whole fan away once the bearing is gone.
Okay.
Yep. But before it's gone, it will make very loud noises, so you know for sure that my fan is going. Yep.
That first one you had up there, I think they had an internal picture of it. It looks like it has like a squirrel cage kind of thing.
Yeah, that's a squirrel cage or centrifugal, forced air cooling system, which means it can be a higher pitch noise because squirrel cage can run at a higher speed. Yep.
Those cards are loud.
Those are loud. The first
top
one.
Yeah. The second one is actually much cooler.
Yeah,
Much
silent.
cooler and silent.
And silent. Yep. Okay. Well, that's good to know. Did you own both at a time or at a certain time?
I know people that have used that design of fans. I personally don't recommend it.
Okay.
They run hotter, louder, and they're inefficient.
They just look more sleek. That's all.
Yeah.
Okay. Yep.
What was the really, go back to sorting them? Well, there's one in the 1,000, over 1,000 range. What was that one like?
Oh, okay. Let's go back to those numbers.
No, back at sorting the video cards, like the price range.
Right.
There's one for really, really expensive.
Oh, okay. You want to look at the really expensive one? Okay, let's go back. Video cards, desktop. And I think we can just sort by highest price first. $1,019. There you go. Yep.
I was gonna say right now, that's actually two $500 GPUs basically mixed into one card.
Okay.
So they're basically combining.
So the price is way overpriced.
Yeah, it's basically two $500 ones and one.
But it takes up only one slot.
Yeah, it takes one slot.
But it's got carbon fiber and cool machine screws on the outside of it.
What I want to do is what I really want to do is to find out the exact power consumption, because I want you guys to learn how to do power budgeting. So let's go to here. The first thing you notice is it has 3,072 CUDA cores. In other words, these cores, you have 3,072 processors that can be putting pixels on your screen at the same time. That's basically what it is. And this is one thing where parallel processing is really helpful. In other words, everything else being the same, this thing is going to be about the 300% of the performance of the one that has only 1,000 cores. Okay, it's really just scalable like that. Okay, 1,000, 2,000, 3,000, you get the performance out of the number of cores. It has more memory, but it does need more memory because it has more cores working at the same time. And what I want to do is to find the power consumption. It doesn't mention anything. Sorry? Where? Oh, but that's a power supply for the entire thing, not just for this card. What if you put two of these things together? Do you need a 1,300 watt power supply? You don't, right? So it doesn't say anything about just the card itself. I'm assuming the high-end processor card would probably draw 300 watts or 400 watts. That's basically what it is. It's a 400 watt power supply just for the card itself. The other thing you can also see is how what kind of power connector it needs, because when we select power supplies, you will see what type of current or power can be supplied by special connectors that connect to a video card.
So there's not an industry standard?
Sorry?
There's not one standard?
That's an industry standard right there. So this one requires two, not one, but two 8-pin power connections. And that's a lot. That's a lot of power just for one video card. Any other questions? Yep.
What does the acronym CUDA stand for?
That's a good question. Let's find out. And we'll go to Wikipedia. CUDA stands for formerly Compute Unified Device Architecture. It's a parallel computing platform and programming model created by NVIDIA and implemented by the GPUs that they produce. So basically, it's just their kind of proprietary name of their graphics processor. Yeah, probably doesn't have any other specific implications. Does anyone know how this type of coprocessor, how it is used to draw pixels, on your screen, or how things are actually organized in the game? Okay, so what do you do? What is on your screen when you're playing a video game? You see objects and stuff like that, right? And most of the stuff that we do are 3D. How many people still play with 2D games? But you don't need a high-end video card for 2D games, okay? Okay, so for 3D games, what's happening? I'm gonna use the whiteboard here. There are several things. The first thing is, the smallest unit of things that you draw on the screen is a polygon. Okay, a polygon simply means it has at least 3 vertices or 3 points connected by 3 lines at least, and this is a flat surface. Okay, it's a flat surface. It is not curved in any way. And then what you do is you have a view angle. Okay, so this is representing your eyes. So your eye is looking at this particular surface, and this surface here, because it's in 3D space, so it can be. Okay, I'll just use this as a prop. So if you're looking at this from your perspective, you can basically select the angle and the placement of this particular object, of this polygon. Now on top of everything else, you also have light sources. So I'll just make this really simple and make one particular light source here. So this is my light source. Okay. In order to calculate, and this is the screen, so the screen is really a projection of this object onto the 2D space. So what happens is, this light source here has to strike this particular surface at a particular angle depending on how this is configured, and then part of that light is reflected, to your eyes. So the calculation is what should be the value of this pixel. Am I doing okay so far with just a general layout of what your 3D processor or what your video card is trying to do? So the calculation of this is parallel to another polygon somewhere else. So the calculation of what you should be seeing for this particular polygon, they can be computed in parallel. They don't have to be, you don't have to compute one and then the other one. And that's why the more cores, then the faster you can render the graphics, because what you're seeing on screen, no matter how complicated an object may seem to be, they're all made out of, guess what? That tiny little polygons, okay? But what about that, really kind of cool looking, kind of, texture on a particular surface? It can be done in 2 ways, okay? The old way of doing things when processing power was not really that impressive, it was called texture mapping. Texture mapping is simply saying, I'm going to, paint this surface with something that looks like 3D, like hair or something like that, but it really is a 2D projection of something that is actually only 2-dimensional. But these days, because of processing power is so abundant, they can actually start to model, the appearance of hair as actual, individual polygons on each, strand of hair. So that's basically how far we have gone, and that's why you can see, more realistic graphics now compared to 10 years ago, where we still have 3D games, but the rendering of graphics is not that impressive. Yep.
Isn't it going to come to a point where our eyes are going to see it so real that there's going to be like a threshold, not technologically speaking, but biologically speaking,
Okay.
as far as what we see on the computer screen or on TV?
There are things that are very hard to render, okay, compared to something that looks like this, because this doesn't take into effect a reflection from other objects. In other words, when we have a normal situation like this in a room, why do we see any? Why isn't the ceiling completely dark? Think about it. Okay, look up and look at the ceiling. Okay, it is definitely darker than the pieces of paper or the screen, projection screen. But why isn't the ceiling completely dark? What is lighting up the ceiling?
Those ones that are reflecting off the outside.
Everything is reflecting. Okay, your desk is reflecting, your clothing is reflecting, the floor is reflecting. So we have a diffusion in this case. It's all based on diffusion. And these processors, as powerful as they are, they cannot take into account of complete diffusion. Okay, let's think about this. Okay, I'm holding up a pen here. Okay, I'm holding up a dry bar marker. Okay, obviously it is reflecting light, but think about all the light that is reflected off of this pen here. What are the sources of those lights? The obvious ones would be these fluorescent lights, right? That's easy to model, no problem. What about that back wall all the way to the classroom? That's one big surface, okay? And it's also producing light that is reflected off of this pen. How many points do you think there are on that back wall? A huge number, right? If you break it down into small polygons, there's still a lot. So that's why in order to make graphics realistic, it still takes a lot of processing power, especially for indoor or enclosed environments. When you're outside, it's not as much of a concern because the strength of the sun as a source of light is much stronger compared to any type of reflected light in the outside setting. And that's why outside scenes can be very realistic with not a whole lot of processing power. But when it comes to indoor type of environments, it actually gets harder. What about reflective, like silver type of objects? Metallic, reflective objects. They're like mirrors, right? So what is one property about mirror-like objects that can make this type of computation expensive? They keep bouncing off, right? So if you have a whole bunch of silver balls in a scene and they are arranged in a way where they can actually see each other, then the computation of what you should be seeing on your screen is now no longer just looking at one single point that's illuminated by a single source, because this object can reflect off of another object, which can reflect off of another object, which is reflected out of another object. So that's why it's more expensive to render graphics like that and make it realistic. What about water, liquid? What happens when you have a game where your game has to track refraction as well as reflection on the surface of a lake?
Sounds processor intensive.
That is extremely processing intensive. Even when you have 3,000 cores working all at the same time, that is still very intensive. Because when you look at the surface of water, it's not a flat surface. So first of all, you have to break it up into sufficiently small, polygons, right? Now, when you look at one polygon on the surface of water, it has two properties, not one. One, it has a reflective property. Okay, water can do reflection, and the second one is it has a refraction property. In other words, this light does get refracted and go down. So whatever is under the water, can be visible along with an overlay of whatever is reflected from the surface of the water. Yep.
But with Moore's law, is there going to be a time in the next 5, 6, 7 years where that's going to be easy for the GPU to process quickly and efficiently?
They will get more efficient. Moore's law basically says, yes, the speed will continue to double every 2 years. But the complexity of a scene that looks like this, what about fog? What about fog? Do you think fog is easy to model or difficult to model?
Extremely difficult.
They're extremely difficult to model because what happens to one single ray of light when it strikes fog? It gets refracted and it gets diffused. Okay, so it gets dispersed in a pattern that is really hard to compute when you're just looking at a single point. Okay, so the bottom line is, yes, with 3,000 cores, 3,000 CUDA cores, with this $1,000, graphics card, yes, you will get more and more realistic graphics. But are we close to the end where you can say, oh, we will be looking at a scene in a game as realistic as you would be in physical world? I don't think we're even close. Okay, so we are running out of time today, but I'm hoping you guys get something out of this discussion. I hope nobody's going to go and spend $1,000 right now and go, I need to have that video card.